Hello, this is Steve Koster with Espresso Engineering. Today we have a chance to catch up with Bruce Archambault of Applied Electromagnetic Technologies. Bruce, how are you doing today?
I'm doing fine. So I was hoping to be able to tell you about a couple of our products that we're pretty excited about.
That's what we're looking forward to that.
So this product here is a spherical dipole radiator. It has a comb generator built into it. And so the idea here is that it's battery operated. The hemispheres themselves are the dipole. And so this can be used either in horizontal polarization or vertical polarization, just by attaching this yoke here to a normal tripod. And then it's used to create electromagnetic emissions, if you will,
right,
in a test lab, so that every morning in the test lab you can check to make sure that your antennas and your cables, balance, or whatever are working. You know, it can cost an awful lot of money if you do a test and you run 3 days and all of a sudden find out somebody stepped on a cable and broke the connector. Right?
Absolutely.
So very fast check. This thing goes from 10 megahertz to 10 gigahertz. So a very wide band test can be done very, very quickly, and you do this on a daily basis and just check to make sure it's the same as it was the day before, you know, and then you go on with your normal business.
Yeah, absolutely, because if you forget to connect the cable or anything, you put this on, you know immediately that your system is ready to go.
Exactly. So also, by the way, this is a very unique thing. There are other comb generators out there, of course, but this is the only one that can actually test your quasi-peak detector. So, as you know, the quasi-peak detector will lower the emission level if you have an impulse that's just happening every once in a while, right?
Correct.
And if you have a sine wave, then the quasi-peak detector and the peak detector will give you the same answer, right? And that's how most people test it, but that's not a very good test. So we have a button on this that you push the button, and it'll pulse the RF on about a 5 hertz rate.
Okay.
And so you can see your emissions drop by 2 to 3 dB, and that's showing that your quasi-peak detector is working.
Is working as advertised.
Right.
Absolutely.
And in fact, I spoke to a salesman the other day, and he was telling me that he actually, we also sell these through ETS Lundgren.
Okay.
And he was telling me that he brought one of these in and showed the customer, who found out very quickly that his very expensive receiver quasi-peak detector wasn't working. And it also helped him discover that he had one of his cables was broken.
Yeah.
And so they sold one almost immediately.
Their value is it's amazing, because being in the test lab industry, I've seen it to where you test all day and all of a sudden you find the cable wasn't connected. No wonder I didn't find anything from that unit. So that's a great option.
Yeah, and it's very affordable too. It's in the low $3,000 range. And so again, battery operated. Batteries run for a good 4 hours to 6 hours of a continuous operation. Very few people use it that long, But it's been very handy.
Now, the question I would have, as it gets close to the battery life, does the emissions fall off, or is it just the same all of a sudden and then just...
It's the same all of a sudden it ends. So we sense the battery voltage, and when we get to the point where we can't maintain the same RF level, then we just shut everything off. So we don't have to worry about that kind of repeatability thing.
As an engineer, you wouldn't be chasing your tail, if you will, because it's lower. Right. Why is it lower?
Exactly.
That's a great option.
And we've done a lot of testing to show repeatability from day to day, or even just turn this thing on and just see how stable is it. And we're talking about a couple tenths of a dB over hours and hours of use. So this is intended to be a quick check for things, but it's turned out to be a lot more stable and a lot more accurate than what we originally designed it for.
That's terrific, because you really do need to do those checks every morning to make sure you're reading the right stuff.
Right. Then we have this other device here, which looks very similar. This is our precision spherical dipole source. Obviously, it's the same kind of spherical dipole, same kind of battery operation inside. But what this has that's different is it has an optical interface. And so what the optical interface does is that you can, on your computer, you plug in a little USB dongle that converts from the USB on the computer to fiber optics, sends up a command over the fiber optics into the synthesizer that's in here, controlling frequency and amplitude. And then there's a detector in here that senses how much energy is actually being applied to the dipole, this spherical dipole here, sends that back down to the computer so that you can adjust the level up and down so get the same level as what you had last year, last week, whatever it is. So much more precise control. And you can only have one, you can set this to one frequency at a time, where over here we had a comb generator, so you're putting energy into all those combs at once. And if we're battery and we're trying to get maximum power out and maximum battery life, then I want to put all my energy into one sine wave and then move it to the next frequency and move it to the next frequency under computer control. So there's a little software that comes with it that gives the user the ability to set frequencies, set step size, set amplitude, and all that kind of thing, and then get this very precise thing. It's especially good for shielding effectiveness measurements, because as you know, when you put, people put an antenna on a table, and then see what it radiates, and then put the antenna in a box on a table.
Right.
But the box will load the antenna, and you might be getting more or less power radiating depending on what it did to the input impedance of the antenna. And so with this PSDS, the Precision Spherical Dipole source, you can have your computer say, okay, do it on the table by itself, and then give me the same amount of power out through this downlink, and that overcomes the loading effect of the of the enclosure and gives you an accurate shielding effectiveness measurement, where the other test I described really is not very accurate. It's emotionally satisfying, and a lot of people do that, it gives you an answer, but it doesn't. It's not really very accurate.
There's a lot of inaccuracy in shielding effectiveness measurements out there that I've noticed.
Yes.
That should help with that.
So we're very pleased with this. We color code them with a different coding, just to see it. But obviously the fiber optics is the main thing here. This is a little more expensive, but it's still under $10,000, and it's kind of a unique product. We don't see anything like that. And obviously,
I haven't heard of anything like that out there.
And obviously, neither of these need an external antenna. They are the antenna by itself.
Right, and you get into shielding effective measurements or even site checks, and if you're off, the first thing you wonder is my source stable?
Right.
So if you have some very stable source, that question goes away, and you're on to the next thing.
Exactly.
Is it my antenna? Is it my cables, etc.?
Another thing that customers use this for is to compare different kinds of test environments. The ultimate test environment is anechoic, semi-anechoic chamber, or maybe an open area test site. But now somebody's got a GTEM because they don't have room for all that stuff. Right. And we've got one customer I can think of right now that has this GTEM, and before he goes to the test lab and spends, $1,000 a day or whatever it is with a test lab to find out he's failing, he'd rather know in advance it is GTEM. But now, what's the relationship between a GTEM test and an open area test site? And so you take a sphere like this, you put them in both environments, and you basically get a correction factor. It's probably not the right terminology, but you get a correction factor that says if you get so much energy in your GTEM, you're going to be at the limit when you go to the open area test site.
Yeah, that's invaluable for pre-scanning at your own facility, actually.
Yeah. And you don't even really need to have something as formal as a GTEM. It could just be in a room or in a small shielded room or whatever it would be.
Some area in your facility where you've got it set up, and you just check the differences between the sites. And because of the leveling, the detecting that's going on inside this thing and the computer control, that you get the same level. And we're talking about down to tenths of a dB. That is terrific.
So that's what's new from Applied EM Technology.
Terrific. Well, thank you for coming by and sharing that with us. It's really exciting. That's good news.
Well, thanks for having me.
I have to get me one of those.